I know that the calendar says 32. This is going on 33. I'll tell you why when we're done. Okay. We just got finished with an activity where we looked at polynomial in behavior, which is what your quiz is over tomorrow. Today, we're going to talk about rational functions in behavior. So as a reminder, a rational function is simply the quotient, which means you're dividing, of two polynomials. Right? And there are three examples there. So remember, you have to have a variable in the denominator for it to be irrational. You don't have to have a variable in the numerator. You can, but you don't have to. If you look at the second example, can I just cancel out these three x's and move on with my life? No, that gets you thrown in math jail and you don't want to be there. That's bad, bad, real bad. Don't do that kind of thing. Okay? All right. So in behavior is tied to our asymptotes, which we already reviewed. So we already know that we know this stuff, but let's talk about it one more time with a little bit more formal language. So we have the in behavior of irrational functions determined by the leading terms. And some of us still struggle with those definitions. Vocabulary is important, not because you're going to have a vocabulary test, but if you don't know what the pieces are, then you're not communicating yourself correctly, or when you read stuff, you don't even know what the heck you're reading. So this whole thing right here, this whole thing in the numerator is a term, one term. The A would be the coefficient, the number that would be there. The X is the variable. The N is the degree. So degree, coefficient, whole thing is the term. Okay, so you can't say things like it has an even coefficient. I mean, it might, but that would mean the number out front is 2. Or it has an even term. That doesn't make any sense. Okay, so just be careful with those sorts of things. All right, so case 1. If your leading terms have the same degree, that means, or in other words, that is tied in degree. If the numerator and denominator are tied in degree, we already know that that means we have a horizontal asymptote and it's just the ratio of the leading coefficients, right? That's old news. Okay. Case 2. The denominator dominates the numerator. Denominator is bigger. That means this is bottom heavy. And then we know if the function is bottom heavy, that we have a horizontal asymptote at y equals 0. It requires no work or any other investigation of anything. Then case 3, which is going to be worded a little bit differently than what we have been saying. The numerator dominates the denominator. Well, that still does mean top heavy. That tells us a couple of things. First of all, no horizontal asymptote, right? It opens the door for a slant asymptote, but it's only, let's jump to the note real quick. If the degree of the numerator is exactly 1 more than the degree of the denominator, then we have a slant or oblique asymptote, okay? But they're not always just one greater. So the result here, it has the end behavior of this polynomial. We're going to come back and talk about that a couple of times as we go through so I can clarify what that means. It's basically, remember that I showed you a picture, which I'll show you again today, but where we could have a parabolic asymptote, right? It's not always a slant asymptote. It can be some other things, but how we get and why those words in behavior there are going to be a godsend for you. We'll talk about that when we get there, okay? We good so far, though? All that sound familiar? All right, so let's just a little bit more review with just going through and figuring out our asymptotes. So it says to determine if we have horizontal, slant, or neither, and if we have one, we need to write the equation. So when I look at A, here are my leading terms. So the numerator degree, oh, that's not an N. My numerator degree is equal to the denominator. That means that they are tied in degree, right? Just another way to notate that. So I do have a horizontal asymptote, and it would be at y equals what? 3/5. Yes, that makes sense? Okay, that's kind of old business, right? Not changing anything here. I put the n equals d, but really, whatever. So then I look at these two. Here, the numerator is less than the denominator, which means it's bottom heavy. Do we have a horizontal asymptote? Yes, and it's at y equals 0. Very good. Okay. Then I look at these two. Here, the numerator is greater than the denominator. So do I have a horizontal asymptote? No. Numerator is equal to the denominator degree plus 1. So what do I have? A slant asymptote, okay? And we're going to go and find that. And I have to find that by doing what? Magic? What do I do? Magic? Magic works, right? But I have to, how do I find what the y equals though? I divide, exactly. So I'm going to divide, no magic, sorry. I'm going to take 5x plus 9, and I'm going to divide it into 2x squared. Do I get to just put 2x squared minus 4? No, what do I need? Yeah, I need a plus 0x minus 4. Okay, I got to have that placeholder. Now, this already kind of looks yucky, right? But it's not the end of the world. I have to take 2x squared and divide it by 5x. If I put 2x squared over 5x, what will that give me? 2/5 times x. See how easy that is? 2/5 x. That's all it is. So I'm going to multiply it back. 2/5 x times 5x is 2x squared. 2/5 x times 9 will give me a positive 18/5 x. Now, I know you already don't like this. Just hang on with me for a minute. These are going to zero out. I get negative 18/5 x minus 4. So then negative 18/5 divided by x divided by 5x will give me a negative 18/25. And then I don't have to go any farther. So my slant asymptote is y equals 2/5 x minus 18/25. Now, that one is kind of purposefully ugly. I left it ugly so that we could actually do that because we were asked for the slant asymptote. Here's some good news. The great majority of the time in AP Pre-Cal, we don't really even care about the line. You know how we don't care about the remainder? We don't care about the whole line. Now, we care about the line in general, but I don't need this specific line. I just need to know some stuff about the line. So it's possible that you could be asked for the actual asymptote, and then you would have to actually do the long division. But as soon as we get through the rest of these, when we flip it over, I'm going to show you why we don't necessarily have to do even that much anymore, okay, as long as we have a good concept of it. So let's pause on that for a minute. Let's do these three, and then we'll come back to that. All right. So when I look at D, and I look at these two terms here, N is equal to D. So I have a horizontal asymptote where? Y equals 1/2. Good. Here, numerator is less than denominator. So y equals what? 0. And here, N is less than D. So my horizontal asymptote is at y equals 0. Now, this negative sign right here, does that do anything to this asymptote? No. What if I had a negative out in front of this? Would that matter for my asymptote? Yes, because then that would make it a negative 1/2, right? So just make sure you don't just ignore the negatives. That sometimes they matter, sometimes they don't, okay? Questions? We good? All right, so now we're going to take all this asymptote stuff we already know how to do, tie it to end behavior. So flip this over. So we're back to writing limit statements, all right? It says write limit statements to describe the end behavior. That means we are at the infinities of the following rational functions. So to do the left in behavior, okay, y'all were doing a really good job of writing your limits, so don't get sloppy now. LIM, the limit as x approaches negative infinity, because that's going to the left, right? The name of this function is f of x. And just in case I forget to say this at the end, on your assignment, at the bottom of the front, you have to write some limit statements, but I have them as y equals instead of function. Anytime you have to name a function and it's not named, it's fine for you to use f of x, okay? We just don't want to use f of x if it's named g of x or something like that, okay? So if you get there, because I've had that question, which is a very valid, very good question. I messed that up, but you can just call it f. All right, so then my right would be the limit as x approaches infinity of f of x. Okay. So I have that part. Now I just got to figure out what my answer is, right? Well, your end behavior is tied to not all of your asymptotes, but it is tied to your horizontal and your slant asymptotes. We have vertical asymptotes and holes and rationals also, but that's more your middle behavior. The other stuff is your end behaviors. So it will be helpful if we know what our asymptotes are. So let's look at A here. I look at my first two terms. Am I going to have a horizontal asymptote? Yes, at y equals what? 1/3. Okay. Do we all agree with that? Okay. So now let me show you a graph. Now this isn't the actual graph. I really should have put the actual graph, but it's good enough. It's a rational function. And we can pretend like this is at 1/3. Okay, so let's just pretend like that asymptote is at y equals 1/3. And again, I have vertical asymptotes, and maybe I have some holes, whatever, but I really don't care about anything that's happening in the middle, because we're talking about what's happening way out here when x goes to negative infinity and when x goes to infinity. So as x is going to negative infinity, this function is approaching that asymptote, right? And as we go to infinity, the function is approaching the asymptote. Even if it crossed the asymptote, let's say it comes down here, and then it would still come back up and approach the asymptote at the ends. I don't care that it I don't care what's going on in the middle. It's about what's happening way out at the end. So the limit as x is approaching either infinity is going to be whatever that asymptote is, because it doesn't even matter if it's coming from the bottom or the top. That's what we're approaching. So our answers here are the asymptotes: 1/3, 1/3. That's it. Okay. The y value is approaching the asymptote, which is at 1/3. Okay. We okay with that? Questions? All right. So let's fill in our limit, the first part of our limits here. Left will be LIM. Limit is x approaches negative infinity of who? G of x. And the limit as x approaches infinity of g of x is B top heavy, bottom heavy, or tied in degree? Bottom heavy. So my asymptote is at y equals what? 0. Which means that at the ends, my function is approaching 0. Okay. What questions do you have? Everybody good so far? It really is that easy. Okay. All right, now let's look at the next one. Let's go ahead and fill in the first part here. Limit as x approaches negative infinity of h of x, and the limit as x approaches infinity of h of x. Okay. Now, is this function top heavy, bottom heavy, or tied in degree? Top heavy. Is it top heavy by 1? Yes. Okay, so will we have a slant asymptote? Yes. All right. So here, again, I could divide the whole thing, right? But I don't have to divide the whole thing, because let's look at the wording difference here. Case 1, it says I have a horizontal asymptote right here. I have a horizontal asymptote right here. This doesn't say I have an asymptote at a specific place. It says we have the end behavior of whatever we get when we divide this. just the end behavior. Nobody said we have to find, like here for these two, you have to find the actual line or it doesn't make any sense. Here, I don't actually have to find the whole slant asymptote. If I go over here and I just take the ratio of these two terms and I put negative 3x to the fourth over x cubed, then I can end up with a y equals negative 3x. Now, is that the slant asymptote? No, because if I was to do the long division, that would be my first term, right? But then I'd have another term. But here's the great thing, something that I know you learn in geometry and then you do it again in algebra 2 and probably in algebra 3, but I don't know for sure, is that you learn about parallel lines. And if we have parallel lines, they have the same what? Slope. So I don't know what the y-intercept, I mean, I could figure out the y-intercept if I really wanted to, but I don't have to. But they have the same slope. So if I have this slope, and I know that a negative slope looks like that, right? So it's tilted like this, and all that's going to change is how high or low it is based on my y-intercept, right? But is the end behavior going to change? No. So if all I care about is the end behavior, I don't care exactly where it is on the graph. Nobody's asking me to graph it or match it with something. I just care about the end behavior. Getting this much can help me draw that line. There's my answer right there. As x goes to negative infinity, where's y going? Infinity, right? As x is going to infinity, y is going to negative infinity, okay? So if you have a horizontal asymptote, the answers to your limits are whatever the y value of the asymptote is. If you have a slant asymptote, just divide just the first terms, get that first term to know if it's positive or negative, and then you'll get the ends there, okay? Does that make sense? Yes, sir. Yes, exactly. Yes, that's good. If it's top, so his question was, if it's top heavy, your answers will always be some sort of infinity, and the answer is yes to that. So in addition to that, so let's just look at this right here. Let me say this another way. Let's pretend, we're going to pretend again, I'm just making up something here. Let's say that we have y equals 4x squared plus 3 over x minus 2. Okay, that's not the actual function, but just pretend like it is. And then I have this blue line here that is the blue line there that is my slant asymptote. If I just divide this and I get y equals 4x, okay, that line right there goes to the origin. We agree with that? That's my y-intercept. So it would actually be right here, but it would be parallel to that blue one. So would that intersect my graph? Yeah, but again, I don't care where it is. If I know that it looks like this, you see how the end behavior of those lines are the same? That's all I'm doing there, okay? You could be asked about something that's not a slant asymptote. Now, the majority of the time, if you're talking a lot of rational stuff right now, we'll be talking about that, but you could be expected to understand something like this. Not by looking at the graph. You don't have to graph it. We don't have to overanalyze it. So remember, the blue part is the actual function. The red part is the asymptote, which is weird, I know, okay? But we have the actual equations here. This is the actual blue function, what it would look like as an equation, and then that's my actual asymptote. If I do basically what I just did, and that would just give me y equals x squared. Well, I know that y equals x squared looks like this. Doesn't this have the same end behavior as this red one? And if that's all we're concerned with, it'd be infinity, infinity. Okay? See how easy that is? We don't have to divide everything out. We don't have to be experts at any of this. It's just simple in behavior. Okay, we good? Questions? All right, awesome. So let's go back over here then. So let's go ahead and fill in our limit statements here. Limit as x approaches what for the first one? Negative infinity. We're going to name this guy m of x because they don't have names. M of x, and then limit as x approaches infinity of m of x. All right. At both infinities, since I have a horizontal asymptote, my answers will be the same. What's my answer? 2. Okay, 2. I'm glad you said that. asymptote is at y equals 2. Here, we just put the 2, okay? Everybody good with that? Questions? All right. Let's name this one k of x. So we get the limit as x approaches negative infinity, k of x, limit as x approaches infinity of k of x. All right, now look at this. You see there's 3 pieces to this function. You see how here this is approaching negative infinity for both of those? Do we care? No, that is middle behavior. We don't care. Good for you. We will talk about limits as x approaches 2 and stuff. We're just not there yet. We're talking about the infinities way out here. I have a horizontal asymptote. So will my answers be the same or different than each other? The same. And they will be what? -1. Very good. Okay. Any questions at all? All right. So now this next part, I've kind of explained this stuff to you as we've gone. Oh, I did want to go back. I told you to revisit this. Here, we did all this nonsense, right? But if all I cared about was in behavior, I could have just divided these and just ended up with that, and it would have got me my in behavior, okay? So, and if you do have to find a slant asymptote and actually divide, I don't foresee you having one all funky like this. I just want you to know if it gets funky, you probably didn't really have to do it, okay? You probably just had to do the first part. All right, but to talk a little bit more about the slant asymptotes, I know I've said this multiple times, but if the degree of the numerator is exactly 1 greater, then you have a slant asymptote that is parallel to the ratio of the leading terms. Okay, that's why we only have to find the ratio of the leading terms, because that'll be parallel to whatever the actual slant asymptote is. This gives you a rational, see that yucky looking polynomial in the numerator and denominator, but if I just take these and divide it, then I get a over b times x to the n minus d, which is what was on the front. And you get and this will just end up being x every time, okay? So we don't have to overthink it. This says, which of the following rational function has a slant asymptote parallel to this line? So again, we don't have to find the actual slant asymptote. So to look at Roman numeral 1, do we even have a slant asymptote? No, this is tied in degree. So my asymptote would be y equals 1/2, but that's not parallel to 1/2 x, right? That'd be a horizontal line. Does this have a slant asymptote? No, this one would be at y equals 0. So that won't work either. Does 3 have a slant asymptote? Yes, it is top heavy. So we get y equals 1/2 x, right? Is that the actual slant asymptote? No, it's what it is parallel to, which is what we want. So we like Roman numeral 3. Everybody with me so far? Yes. Okay. So then here, this is top heavy, but if I divided that, I'd get y equals 1/2 x squared, right? That'd be parabolic. That would look like this. So they don't have the same in behavior. It's not parallel, not even a slant asymptote. So it is 3 only. Okay. What questions do we have? Anything? You got this? All right, I'm going to give you 2 things. Oh, this is going on page 32. I'm sorry, 33, because page 32 is your title page for the second 6 weeks. You can just write second 6 weeks real big. That's your title page, and then this goes on 33. I'm going to give you the review for your Thursday test and your assignment. All right?